Hi friends, this is Naresh. In this class I am going to explain about engineering drawing, and today's topic is plane scales. In this class we will discuss about construction of plane scales. Already in previous class we have discussed about representative fraction and full size scale, reduced scale and enlarged scale. It is not always possible or convenient to draw drawings of an object to its actual size. For instance, drawings of very big objects like buildings, machines uh, cannot be prepared in full size because they would be too big to accommodate on the drawing sheet. Drawings of very small objects like precision instruments, uh, watches, electronic devices, circuits also cannot be prepared in full size because they would be too small to draw and to read. Okay, therefore a convenient scale is always chosen to prepare the drawings of big as well as small objects in proportional smaller or larger sizes. So the scales are used to prepare a drawing at a full size, reduced size or enlarged size. Okay, if we show the actual length of an object on a drawing, then the scale is called full size scale. If we reduce the actual length of an object so as to accommodate that object on drawing, then the scale usually is called reduced scale. Such scales are used for preparation of drawings of large machine components, buildings, bridges, survey maps, architectural drawings like this. And similarly, drawings of small machine components, mechanical instruments, watches, precision instruments are made larger than their real size. They are said to be drawn in an increasing or enlarging scale. Okay, for subject point of view, the scales are represented by a value, RF value. So RF means representative fraction or representative factor. Here the formula for RF is the ratio of dimension of drawing to the dimension of object. Here dimension of object means size of original object. Okay, actual size. Dimension of object means actual size of an object. Dimension of drawing. Dimension of drawing means the size of object on drawing sheet. Okay, so therefore the ratio of RF, the ratio of dimension of object on drawing sheet to the dimension of object, original size of object. Okay, now for in case of plots or areas, RF value equal to square root of area of drawing divided by actual area of an actual area. For in case of objects, three-dimensional objects or volumes, the value of RF equal to cube root of volume as per drawing divided by actual volume. Okay, for calculating the value of length of scale equal to RF into maximum length to be measured. These formulas are used in our problems. Now these are the important metric formulas. 1 kilometer equal to 10 hectometers. Again 1 hectometer equal to 10 decameters. Again 1 decameter equal to 10 meters. Now 1 meter equal to 10 decimeters and 1 decimeter equal to 10 centimeters. 1 centimeter equal to 10 millimeters. Similarly, uh, 1 feet or 1 foot equal to 12 inches. Okay, 1 inch equal to 2.54 centimeters. Similarly, 1 yard equal to 3 feet. Okay. Now, in subject point of view, scales are classified into plane scales, diagonal scales, Vernier scales, comparative scales, and scales of chords. In this class, we will discuss about these plane scales. Plane scales are used for dimensions up to single decimal. For diagonal scales, for dimensions up to 2 decimals. Okay, to measure the dimensions up to 2 decimals. Here, in case of Vernier scales, you can read the dimensions up to 2 decimals inaccurate. Comparative scales are used for comparing two different units, whereas a scale of chords is used for measuring or constructing angles. Now coming to the problems. Now the first problem is draw a scale 1 centimeter equal to 1 meter to read decimeters to measure maximum distance of 6 meters. Show on it a distance of 4 meters and 6 decimeters. Okay, here here the 1 centimeter equal to 1 meter means 1 meter means actual size of an object and 1 centimeter means uh, drawing size of an object. So it is useful for finding the value of RF. Okay, already we discussed about RF, representative factor, that is RF equal to size of drawing divided by actual size of object. So here the size of drawing is 1 centimeter divided by actual size of object equal to 1 meter. So therefore RF equal to 1 centimeter by 1 meter, that is equal to 1 centimeter by 100 centimeters. So 1 meter equal to 100 centimeters. Therefore RF equal to 1 by 100. Okay, the value of RF must be in same dimensions. Okay, so the length of scale equal to RF into maximum distance up to measure. Here the maximum distance up to measure is 6 meters. Okay, now RF equal to 1 by 100 into 6 meters. 1 meter equal to 100 centimeters. Therefore 6 into 100 centimeters. Totally the length of scale equal to 6 centimeters. Okay, now these are the steps to construct the plane scale. Okay, first of all, draw a horizontal line, that value equal to length of a scale. So here the length of the scale is 6 centimeters. Therefore you have to draw a horizontal line and its length is equal to 6 centimeters. Now divide this line into 6 equal parts, because here in given question the maximum distance up to measure is 6 meters. So you have to divide this line into 6 equal parts. This is 0, 1, 2, 3, 4, 5 and 6. Okay, place 0 at the end of first unit. Okay, 1 2 3 4 5, and this is sixth part. Totally 6 parts. Now this is 1 meter, 1 meter, 1 meter, 1 meter, 1 meter, and 1 meter. Here the main division is 1 meter, and the subdivision, this main division divided into 10 equal parts. That is the subdivision, 10 subdivisions. So here I divided this main division into 10 equal parts. That is 1 by 10, 1 by 10, 1 by 10, 1 by 10, 1 by 10. Okay. Now you can take the height of scale equal to 5 mm or 10 mm. Okay, take height of scale equal to 5 mm or 10 mm for getting a look of scale. Okay, after construction of scale, mention its RF and name of scale. Okay, the main division is meters, and subdivision is, each division is decimeter. That is 1 decimeter, 2 decimeter, 3, 4, and 10 decimeter. Already in previous slide we have discussed about metric units. That is 10 decimeters equal to 1 meter. Okay, 1 meter equal to 10 decimeters. Therefore each subdivision is decimeter. Okay, the main division is 1 meter, 1 meter, 1 meter, 1 meter, 1 meter, but the subdivision is 1 deci, 2 decimeter, 3 decimeters, 4, 5, 6, and 10 decimeter. 10 decimeters equal to 1 meter. Okay, these are the subdivisions, these are the main divisions. Now you have to show a distance of 4 meters 6 decimeters. Okay, you have to mark a distance of 4 meters and 6 decimeters. Now take here 0 1 deci, 2 3 4 5 decimeters, 6 decimeters. So from here to here the length is 6 decimeters, and 1 meter, 2 meters, 3 meters, and 4 meters. So from here to here the value is 4 meters plus 6 decimeters. You have to draw a line like this. So the total distance between these two vertical lines is 4 meters plus 6 decimeters. Okay, this is the our required plane scale. So now coming to the another problem. In a map, a 36 kilometers distance is shown by a line 45 centimeters, 45 centimeter long. Calculate the RF value and construct a plane scale to read kilometers and hectometers. For maximum 12 kilometers, show a distance of 8.3 kilometers on it. Okay, here in given question, the actual size or actual length of a map is 36 kilometers, but it can be represented by 40 centimeters on drawing. Okay, so the size of drawing is 45 centimeters, and the original size of drawing is 36 kilometers. Therefore RF equal to size of drawing divided by original size. So size of drawing equal to 45 centimeters divided by original size 36 kilometers. You have to convert into same dimensions. Okay, so 1 kilometer equal to 1000 meters. Again 1 meter equal to 100 centimeters. So totally 1 lakh centimeters. 1 kilometer equal to 10 power 5 centimeters. Therefore 45 divided by 36 into 1000 into 100 equal to 1 by 80,000. So the value of RF equal to 1 by 80,000. Okay, so the numerator value and denominator value must be in same units. So now length of the scale equal to RF into maximum distance up to measure. Here the maximum distance up to measure is 12 kilometers. So you have to measure up to 12 kilometers. So the maximum distance is 12 kilometers and the RF value is 1 by 80,000. So 1 by 80,000 into 12 kilometers equal to 15 centimeters. So length of scale equal to 15 centimeters. You have to convert this 12 kilometers into same 10 power 5 centimeters. So 12 into 10 power 5 centimeters. So total the value is length of scale equal to 15 centimeters. So for getting the plane scale, you have to draw a horizontal line. This horizontal line is equal to the length of the scale, that is 15 centimeters. So from here to here the length of the scale equal to the length of the line equal to 15 centimeters. Okay, now divide this scale, this line into 12 equal parts, because here in given question the maximum distance up to measure is 12 kilometers. Therefore you have to divide this line into 12 equal parts. 1 0 1 2 3 4 5 6 7 8 9 10 11 12. So from here to here 11 for subdivisions. This is I consider this first division as a subdivision. So from here to here the total divisions is 11 and first to the plus 1, that is the total value is 12 divisions. So now I divided this first main division into 10 subdivisions. Okay, this each main division represents 1 kilometer, but this each subdivision represents 1 kilometer by 10 parts, that is hectometer. Each subdivision represents 1 hectometer, that is 1 hectare, 2 hectometers, 3 hectare, 5 hectares, 10 hectometers. So 10 hectometers equal to 1 kilometer. Okay, 10 hectometers equal to 1 kilometer. Okay, take height of scale, it is 5 or 10 mm for getting a look of scale. Now you have to you have to represent the main division here and subdivision here, and RF value is here. Okay, so each main division here, in this case each main division represents 1 kilometer and each subdivision represents 1 hectometer. Okay, that is 1 by 10 kilometer. 1 by 10 kilometer equal to 1 hectometer. Okay, now mark the distance of 8.3 kilometers on this scale. So by using this plane scale, you have to show the value of 8.3 kilometers. Okay, you have to show the value of 8.3 kilometers on this scale. From here, from 0 to this, the total. Okay, here from this line to this line, the total distance is 8.3 kilometers. Okay, so from here to here, the number of main divisions is equal to 8 plus 3 hectometers. Therefore 8.3, the total distance between these two vertical lines is 8.3 kilometers. 8.3 kilometers means 8 kilometers 3 hectometers. Okay, this is our final required shape of plane scale. Now coming to the another problem, the distance between two stations is 210 kilometers. That means it is the original size of original size of object, or original length of the object. A passenger train covers this distance in 7 hours. Construct a plane scale to measure time up to a single minute, and the RF value is 1 by 2 lakh. Indicate the distance traveled by train in 29 minutes. Okay, first of all you have to find the value of length of scale. So length of the scale equal to RF into maximum distance up to measure. Here the maximum distance per hour. Here the RF value is 1 by 2 lakhs into maximum distance up to measure is I took rounded value, that is round of value equal to 30. Okay, 30 kilometers. Okay, now the length of the scale equal to 15 centimeters. So you have to draw an horizontal line, the length value equal to the length of horizontal line equal to length of the scale equal to 15 centimeters. Now this is the shape of a plane scale. So from here to here, the length of the scale equal to 15 centimeters and the height of scale equal to 5 or 10 mm. Now I divide the bottom line into 6 equal parts. Here you have to represent the value of 14.5 kilometers, distance traveled in 29 minutes. Okay, here okay, first of all you have to draw an horizontal line. That horizontal line equal to length of the scale. Here the length of the scale equal to RF into maximum distance per hour. Here I consider the maximum distance per hour equal to 30 kilometers. Okay, 30 kilometers per hour. The speed of a train equal to 30 kilometers per hour. Okay, so therefore the length of the scale equal to 15 centimeters. So that value equal to, from here to here the length is 15 centimeters, and I divided this horizontal line into 6 equal parts, because this train covers 30 kilometers per 1 hour. Okay, so from here to here is 1 hour. Okay, so 1 hour, so 1 hour means 60 minutes. So I divided this horizontal line into 6 equal parts. So therefore each main division represents 10 minutes. So 10 minutes, 10 minutes, 10 minutes, 10 minutes, 10 and 10. Totally from here to here 50 minutes, and from here to here 10 minutes. Totally 60 minutes. That is 1 hour. Okay, for each 10 minutes, it covers a distance of 5 kilometers. Okay, train will covers 5 kilometers per 10 minutes. Okay, so therefore I represent this in kilometers, that is 0 to 5 kilometers, 0 to 5, 10, 15 kilometers, 20, 25. Total the length is 30 kilometers. Okay, here the question is indicate the distance traveled by the train in 29 minutes. So you have to show the distance, traveled by the train in 29 minutes. So from here to here the distance is 29 minutes. So therefore it is equal to the 14.5 kilometers. So the train will covers 14.5 kilometers in 29 minutes. Okay, now represents now show okay, thank you.